Hello, my name is Joe Bonke. I'm a machine tool instructor here at North Central Technical College. I would like to welcome you to our lab space here today. I'm going to give you a brief introduction of what we do here. In our machine tool program here at North Central Technical College, we use a lot of engineering drawings. So our engineers in industry actually draw this piece of paper, and our job as machinists is to take this and turn it into the real life object. So step one is basically going to be using our saw. We take raw materials. It could be steel, aluminum, plastic, pretty much anything that can be machined that's somewhat rigid, and we can turn it into our finished parts. So on our drawings, our engineers are going to tell us what material we need to use and give us all of our tolerances. On this project here, our students are taught how to read blueprints, and they understand how to see the front view, the top view, and the end view of a print. So from there, we have to take this information and choose which machine we're going to be doing it on. So the first thing we do would be saw to rough length, and then from there we would have to move to probably a milling machine to do this project. So let's take a little walk over to our manual machining knee mills that we have here. So you can see in this lab space that we're using here today, we have about 20 manually controlled knee mills in this room. So we have enough room for a lot of capacity for students, and you can see that every student has their own workstation then. So you're responsible for your own area. You have your own tool cart, you'll have a machine to use for the day, and when you're done at the end of the day, you clean it up and leave it in an environment just like this. So this project here is going to require some milling, whether we're doing face milling, end milling, doing some slots, and drilling and tapping holes. That would be done on a machine like this. So very similar to a wood router. If you have any woodworkers in your family, that would be a very good similarity that we do with routing or with milling is similar to a wood router. So let's go look at some lathe projects next. This is another example of a project that we'll be doing here in our program, and you can see this is a very simple project. It's made out of round material, so since it's round, that suggests that we're probably going to be making it in a lathe. So this project here, it's very basic. We assume that our students are starting from nothing, and we build them into skilled machinists. So this is our first manual lathe project. Basically, you take the rough material again from the saw. We're going to saw it to a rough length, and we put it in a machine like this. This machine is different than a milling machine because I can hang on to the material and it'll actually spin with a cutting tool in the machine. So it's really good to make round parts. You can put any shape you want in there. It doesn't have to be round when you start, but the end result will be a round part.
Hello, I'm Jeff Block, one of the machine tool instructors here at North Central Tech. So Joe kind of talked you through a little bit about the manual machining process, how we get going, go from the saw, take it over to a machine, start making some parts. I'm going to show you a little bit of the CNC aspect of it. So as you progress your education through the school, you'll be going from the manual machines into the CNC machines. So we just happen to have a project kind of going through right now. We're making some pumpkins. So it's for an event that we got coming up. So the concept really starts with some software. So this is in SolidWorks. The machinist more than likely probably is not designing this, but this is what you start with. So an engineer comes up with this and say, okay, this is what I want to make. And from there, they would give you something that what they call a part print. And if you notice, if you remember some of the prints that Joe showed you, they had a lot more dimensions on it. This has very few dimensions on it, just for the simple reason that it's a real complicated part. So what we do as a machinist then, we take this from the engineer and we put it into what we call CAM software. And from here, basically what we're doing is we're taking that solid model and we're going to create a program that's going to run on our CNC machines. So the reason why there's no dimensions on the prints, because we can just pick on geometry. If I want to machine the top of the pumpkin, I can just pick on that, and I can tell the machine, the software, how to do it. And what's really kind of neat is that after you have it all programmed, you can actually simulate it to see what the part's going to kind of look like when you're machining it. Software is very powerful. It creates huge programs that would just really be impossible to write by hand. So that's the whole machining process as it would be actually machined in the machine. And it's really amazing how accurate this is. If I see that there's something wrong on this simulation, more than likely when I actually go to machine it, it's going to be wrong as well. So it saves a lot of time machining the part along with material as well. And then from there, basically what you do is you get a finished product, something like that. So the project that we got going, we're going to have students pick the faces that they want and put some kind of a saying on it using the software like that. So that's kind of a great example of how we use software on complicated parts. Now that is made on a 3D milling machine, meaning it moves in 3 different axes. I'd like to show you another machine over here that's very similar to that machine. So this is what they call a 5-axis machine. So if you want to come around here, you can see that vise. So this machine has the capabilities of actually rotating our part. Okay, and it also can spin it. Okay, so this is a part that we made on there. The part was basically held like this. Machine the round sphere of it's actually a half a golf ball, and then it just kind of kept on rotating that part around, and it put all those dimples in as you would see on a golf ball. A couple other parts that we made on this machine. This is off of a trophy that we had made. So this one here, machined the outside, machined that flat, and then it tipped it to put that Timberwolf logo and the machine tool name on it. Couple other parts that you may recognize that we can make in the shop. Trailer hitch ball. Okay, so in one machine we basically did this whole setup using the lathe to make the round features, and then we turned that lathe into a mill basically to put the flats on the part as it goes around. Another example of this, if we have any tractor nuts out there, okay, this is a cover that would go on a PTO. Okay, so this was done on 2 setups. We did the inside features, turn it around, put the threads on there, and then the same thing, we put the square piece on there, turning that lathe into a mill. So it's just kind of a neat example of the different types of machines that we have here. And it's really your imagination that holds you back. If you can think of it, come up with that 3D model of that part, more than likely you got the machines here to make it. So one of the things I wanted to talk to you about is what could happen after your 2-year technical diploma through machine tool techniques. There's a number of different avenues that you can go to. One of the places you can end up in is being a tool and die person. So everybody says, what is tool and die? So basically what tool and die is you're making a tool that a lot of times is going to punch something out of a piece of metal. Probably the concept that just a lot of people can remember or relate to is a 3-hole punch. So I could put a piece of paper in here and I press that down, what happens? Well, there's something that's actually called a punch, the round part, that goes through a hole that's called a die, and it pierces out that piece of paper. Well, we can do the same thing with metal. Okay? So our students in their 4th semester actually make a fishing lure. Okay? So they make all the components that would make that fishing lure. So this is just a part of it, so they have to make the other assembly parts of it. But basically what you're going to do is you're going to start out with a piece of flat stock. See if I can find one here quick. They would lay it down in there, and then in a punch press, basically what this would do is this would come through, punch through that piece of metal, and you end up with a part like this. So this is scrap. What we're actually after is that part on the inside, which is actually your fishing lure. Okay? So you also notice that it's not flat. So the other thing that the students have to make are the form dies for that. So using the software in the machines and 3D milling that software, they create that form that when they put that flat piece of stock in there and they press that together, and then you get your curved fishing lure. So obviously it's not painted. We had a very talented student that was very good at painting lures, and he did that for us and left it here before he left. So kind of a great example of the tool and die industry. So with that tool and die industry, one of the machines that you're going to actually use is what we call a wire EDM machine. So basically what happens here with this machine is it'll cut anything that's conducive to electricity with sparks of pulses of electricity, basically exploding the metal. It's a fairly slow cutting machine, but it's a fairly accurate machine. So one thing that this machine cannot do is create a hole in the material. So it already has to have a hole in it. But basically what it can do is cut very accurate pieces of metal. So the process to cut this out is we had to have that start hole. So that's where our wire is going to go in. It's going to come through and then cut this out. And then basically what it does is it holds onto it right here while it does its finish passes. Okay, so this is the part in this case that we want to keep. And then over here there would be another hole in here. It comes through and it cuts that out. We throw that away and it goes through and finishes that finish passes on our what would be our die opening. And then what you have is a very tight, very close fitting part. So very tight tolerances. It's a super accurate machine, and it can be pretty much run unattended, meaning that I can run a program, I can maybe come back in 3-4 hours, and my part's done. Another thing we can do with this machine is actually cut two different shapes, top and bottom of my part. So here, if you have like you picture a clover, and then on the bottom is actually a heart shape. So here, all in one, that wire can kind of wiggle its way around at different angles, and it basically creates those two different shapes, top and the bottom of that part. So it is actually kind of a cool machine, especially when you even think about this is what cuts that material. Okay, so that wire is about 10 thousandths in diameter, which is probably about 5 times the thickness of a piece of hair, but this will cut actually up to 11 inches of material all in one pass. Because like I say, the wire never actually touches the metal, it just does it with pulses of electricity. So kind of a good example of what a tool and die person would use on the job. Another great thing about the machine tool diploma is it can be used just about anywhere in the US. It's accepted all over the place. We've had students get hired on oil wells down in Texas. You go out to the shipyards out east. So it's kind of a very wide open education once you get your diploma and where you can go after that. So
if you're wondering if this program is right for you, I think if you're a hands-on person, mechanically inclined person, or you like to work with your hands, do things like that, this would be a good program for you. In our curriculum here right now, we spend 20 hours a week in the machine shop. All of our program classes are applied to what we do. So you're taking a print reading class that is specifically for machine tool students. Even our math class is for metalworking trainees, is how it's titled on the book. So it's all applied to what we do in this program. Now when I say applied, I'm not going to say it's easy, but it's directly career focused to what we do in this room. If you would like more information or a shop tour or have any questions on what you've seen in the video, just stop down the machine tool program here or email admissions@ntc.edu and we can answer all your questions.